All right. So we left off with 2 out of the 3 FOL sentence types already accommodated, right? We know how to use interpretations to make atomic sentences true. We know how to use interpretations to decide when sentences with one of the connectives as their main operators could be true or false. The last one, the hardest one, is what to do with the quantifiers. And this is what we're going to talk about for the next 15 minutes or so, and then we'll talk about what we can do, why we're interested in truth in FOL. So we're going to use the same symbolization key. Apologies if you don't know lots about The Simpsons, but that's okay, because it's just an example. So let's think, how will we make sense of sentences whose main operators are quantifiers? Well, the things to remember are what the quantifiers say, right? The existential tells us, hey, there's at least one thing you can plug in for X that makes the sentence true. Whereas the universal tells us, hey, everything in the domain can be plugged in and makes the sentence true. So, very bluntly, an existential is going to be true if there's even one thing in the domain that we can plug in for the associated variable that makes the relevant sentence true. It's false if there's nothing in the domain that does that job. And the universal is going to be true if you can literally plug in every single thing. So if there's even one that you can plug in that makes the embedded sentence false, the universal is false. We'll talk through that a little bit. But there's a complication here. And our example already brings it out. When we talk about plugging things in, we don't mean plugging in their names. Because lots of times, there'll be more objects in the domain than you have names. Easy example, take this one. The domain includes lots and lots and lots of things that we have not specified the names of. So we need to think about ways that we could talk about plugging in the objects, even though we don't have names for them. And the general idea is that all those things that are in the domain that we don't actually have a name for in our interpretation, we could have named them. We can extend our interpretation by adding a name for the thing that's already there. That is, we can extend our interpretation, adding names to pick out stuff that's already in the domain. And if there's one extension where we can do that and plug that name in, the existential is going to be true. If we can do that for every single name, the universal is going to be true. So we'll talk through these one by one, and we'll go through all 4 of these. But let's start really quickly, just kind of before we dive into the mechanism, and think about the truth or falsity of these sentences using this interpretation. So take our first one, right? This sentence effectively tells us there's someone in the domain who's older than Homer. Can we think of any Simpsons characters that are going to be older than Homer? Lots, right? Grandpa Simpson, Mr. Burns, the old mole man. Right? Actually, there's an episode of these that has Mr. Burns where he's old when the dinosaurs were around. So I think he's probably the oldest character, but this is really hard to tell, right? But anyway, there's plenty of things that are older than Homer. So our first sentence, is it going to be true or false? Our first sentence is true. There's something in the domain, at least one thing, that's older than Homer. How about our second one? Our second sentence basically tells us, like kind of translating back, it tells us, hey, there's something in the domain that's older than Maggie and isn't American. Something in the domain that isn't American and older than Maggie. True, false? And this is where we gotta, again, take a second, use our little Simpsons lore, right? Groundskeeper Willie is an easy example, right? He's famously, viciously Scottish. He's clearly older than a baby. There's the Mexican Bumblebee Man. right? Again, older than a baby, non-American. You can see how this game kind of goes, right? So, is there something? Yes. Cool. Bang. Note, in every case we've talked about, the objects we've picked out aren't named in our interpretation, but we know they're in the domain. So we could add a name. We could extend our interpretation to add the name for them, and that would let us plug it in. How about our third one? Is it true that everything in our domain is either American or not American? I mean, even the fucking space aliens, they're not American. So cool. It looks like anything in the domain that's a character is either going to be an A in the extension of A, or it's not going to be. And that's true for everything in the domain. It doesn't matter who we pick. Again, we kind of see the idea here, right? And how about our last one? How about our last one? Last one's tricky. What does our last one say? So this is where it's helpful to kind of work backwards, right? Our last one says something like, hey, for everything in the domain, there's somebody in the domain that's older than them. So for every individual in our domain, there's somebody older. What do we think? True or false? Right? Why is it going to be false? Yeah, or at least there's ties, right? Even if there isn't an oldest, there's going to be ties. There's no guarantee of a kind of infinite number of characters, every which case there's somebody older. Remember the joke I told you, like literally about a minute and a half ago, where Burns was like ancient with the dinosaurs? He's probably the oldest. Cool. He would be somebody we could plug in for X that we could not then find someone to plug in for Z. This is really the process here. Now I'm going to give it to you informally. I'm then very, very quickly going to give it to you in the full formal presentation. If you understand the informal mechanism, you've got the idea. So let's go through them one by one. We've already talked about them, but let's go through them one by one to be very clear. So for our first one, we have the existential quantifier, and we're going to figure out whether it's true or false by seeing, hey, is there some way that we could extend our interpretation, that is, add a name for something we know is already in the domain, and when we extend our interpretation, we then have an object or a name we can plug in. So easy, sure. We can extend this interpretation by introducing the name B for Mr. Burns. I told you earlier he's older than Homer. So cool. This extension gives us a name that we can then replace the X with to get OBH. And OBH is true. The ordered pair B, H is in the extension of O. That is, Burns is older than Homer. So far, so good. Do we see the kind of process here? And again, note the extension here isn't adding new things because Burns was in the domain. It's adding names we didn't have. Okay, so our first one comes out true, just like we wanted. And our second one, remember, our second one here says, hey, there's something that's older than Maggie and isn't American. The example I gave was Groundskeeper Willie. So, cool. We know he's in the domain. We also know we don't have a name for him in our initial interpretation. So we can extend it by introducing a name that picks him out. And then when we have that name, we can plug it in place of the X to get OGM, conjunction, negation, AG, which is then something we can, using our extended interpretation, determine is actually true. Effectively what we do, this process, for the existential, is we see, is there even one potential extension? If there's even one potential extension, the existential's true. Existential's easy. Is there even one object in the domain that does the job? Yes. This one. So the extended interpretation is kind of the red block with this bolted on extra name that we didn't have. And by extending the interpretation, it lets us construct this sentence. So basically think, whenever we say interpretation, think something like symbolization key. And effectively, when we talk about extensions of our interpretation, we're saying, hey, let's take the thing we had and let's add some names for stuff that we know is in the domain, but we just didn't have already. I know that Groundskeeper Willie's in the domain, but at least in the red box, I didn't have a name for him. So let's bolt on a name. And then it becomes really easy. This existential just becomes something that I can plug in a name. But again, the general thought here is that an existential claim is going to be true if there's at least one thing in the domain that you can plug in place of the relevant variable, and the embedded sentence is true. I'm just telling you the machinery of how to do it, but this is the basic idea. Okay. Existentials, easy. Universals, a little harder. So remember, this sentence, this one said basically, hey, everything in the domain is either American or not. Well, okay, we're going to do the same process of building an extension on our interpretation. We're going to do something kind of dirty. We're going to add a name that doesn't stand for any particular individual. In fact, it's going to stand for every individual. It's basically a name that's kind of, it stands for everyone. Effectively, it's a shorthand way for us to introduce a single name that, when we plug it in, basically refers to every object in the domain consecutively. It's cheating grammatically, but it's very effective. Because what we can do is plug the name in, and we get a sentence featuring that name, and it's going to be true as a universal if it doesn't matter who that name names. That is, it doesn't matter who it actually stands for. Assign it to Groundskeeper Willie. Assign it to Maggie. Assign it to Homer. Assign it to the fucking space aliens. Go nuts. Doesn't matter who A actually picks out, because the sentence is always going to be true. That's the kind of underlying thought here. But again, the core thought of a universal claims true if you can replace the associated variable with everything in the domain. If there's even one thing that you can plug in there that doesn't make it work, then the universal is false. This is why, again, we talked about a couple times, universals really hard to make true, and why they're often associated with conditionals. By linking them with conditionals, you make it much easier to make the universal true. Because if it has to be literally every single thing in the domain, it's really rare that that turns out. Okay, and then our last sentence. Our last one, remember our last one, it said for everything in the domain, there's somebody in it that's older than them. And we knew that that was false. We knew that that was false because there's probably going to be an oldest one, or at least tied for oldest one. So how would we show that? Well, we show this by extending our interpretation, introducing a name, A. And let's have A stand for the oldest Simpsons character. We don't care who it is. Probably Mr. Burns, but it could be somebody else. We don't really care. Just let it be whoever is the oldest. Well, once we have A, we plug that in place of X. And the problem then becomes, once A is plugged in, we cannot extend the interpretation further to find some name B. We can plug it in place of Z to get a true sentence. Effectively, you satisfy that first bit and then find there's no way to satisfy the second. And that's why the sentence comes out false, right? There's bound to be at least one person in the domain, the oldest, for whom there is no one that's older than them. So I mentioned this example not because it's fun to talk about who's the oldest Simpsons character, though that is true, but because the process, when you have multiple quantifiers in front, you literally just work from the outside in. We figure out, okay, what can we plug in for the outermost quantifier? And then we look at the next one. And then if there's more, we look at the next one, and so on and so on and so on. Now, I'm going to go really heavy into the weeds for the next 2 minutes to give you the same stuff we just did in slightly more formal language. But the basic idea, again, if you have an existential, just look and see, is there even one thing in the domain that does the job? If you have a universal, does every single thing in the domain do the job? If there's none, the existential is false. If there's even one, it's true. If everything does, the universal is true. If even one doesn't, the universal is false. Now, this is the slightly more complicated version of the same thing we just talked through. Suppose sexy swash font A is a formula containing at least one instance of variable x, and x is free. It's not bound by any quantifier. Well, we can talk about a name C that we can replace x with. This will give us an instantiating name, basically the name we're plugging in. If you do this instantiation, this replacement, you get what we'll call a substitution instance, effectively just plugging in a name in place of the associated variable. We can then, using that terminology, give a strict definition of when universal and existential quantified sentences are true or false. We'll say for all x, AX is true in an interpretation if and only if the substitution instance C is true in every interpretation that extends the original by assigning an object to any name C. This is the same thing we talked about just in slightly more flowery language a second ago. Similarly, our existential is going to be true in an interpretation if and only if there's at least one substitution instance where plugging the name in gives us a true sentence. This is just, again, kind of making sure our formal ducks are in a row. If you understood what we were saying 2 slides ago, you're good to go. Okay, so we've got a grip on truth in FOL. It's always going to be relative to interpretations, and we know how to figure out when any kind of sentence in FOL is true or false. Why the hell should we care? Why is this interesting? Well, because what we can now do is build back all of those semantic notions we had for TFL, but using interpretations and our new sexy language. So now that we have truth in FOL, we can use it to make sense of relevant semantic notions. These are going to be very similar to all the concepts we had in TFL, with one massive difference. Remember the magic word when we were thinking about semantic notions in TFL. Everything was defined in terms of valuations. Assignments of truth values to atoms. We don't have those anymore. Instead, everything is now going to be defined in terms of interpretations. The models that we just talked about constructing. Our cornerstone here is going to be something very similar. We're going to use the double turnstile symbol again. But notably, our double turnstile, when we're using FOL, no longer expresses tautological entailment. Because tautological entailment was defined in terms of valuations. Now, our double turnstile represents full-blown, capital L, logical entailment. In fact, between friends, the TFL stuff was a way for us to get to here. So if you see the double turnstile with FOL sentences, it's saying logical entailment. So when do some FOL sentences entail an FOL conclusion? Well, A1 through AN logically entail C if and only if there's no interpretation that makes A1 through AN true and C false. Does that look familiar? It's fucking validity, right? But note now, it's defined in terms of interpretations. So we've moved up in the world, right? Before, we had a notion of tautological entailment for TFL, defined in terms of valuations. Now we have a parallel concept defined in terms of interpretations, the things we were just talking about. So what this means is that we now have another way to assess arguments for being valid or invalid. We have an argument that's expressed in FOL. So we have some premises in FOL and a conclusion. And we'll say that this argument's valid in first order logic if and only if there's no interpretation that makes the premises true and the conclusion false. On the flip side, an argument is going to be invalid in FOL if there's even one interpretation that makes the premises true and the conclusion false. And in fact, what I'm going to ask you to do is I'm going to give you arguments, and I'm going to ask for you to show me that they are invalid. To do that, what you need to do is construct an interpretation that makes the premises true and the conclusion false. Funnily enough, I will never ask you to show me that an argument is valid using FOL. We'll talk about why in about. But note, again, what we have now is another tool for assessing the validity or invalidity of arguments. Take a natural language argument, symbolize it into first order logic, see if you can construct an interpretation that makes the premises true and the conclusion false. If you can build even one, then the premises do not guarantee the truth. But this isn't the only kind of semantic property we might be interested in. We have parallels for every semantic notion. So before, we had being a tautology. Now we have being a logical truth. A sentence of FOL is a logical truth if and only if it's true in every interpretation. That is, there's literally no interpretation that makes it false. Similarly, an FOL sentence is a contradiction if and only if it's false in every interpretation. That is, there's literally no interpretation that makes it true. This again parallels the notions we had before of being a tautology and being contradiction, but those were defined in terms of valuations. We also have joint consistency and inconsistency. Some sentences are going to be consistent if there's even one already screwed up. If there's even one interpretation that makes all the sentences true. And they're going to be inconsistent if and only if there is no such interpretation. Note again, this is the same kind of notions we've dealt with in the very first lecture, and now we're coming back and we're characterizing them in terms of these notions of interpretations, extensions of predicates. So we can define these semantic notions. But more importantly, we can use interpretations to test for them. Notably, what we can do is show negatives. If you have an FOL sentence, you can show that the FOL sentence is not a logical truth. And you do that by constructing an interpretation that makes it false. Basically show that it's not true in every interpretation by saying, here's one where it's false. Similarly, you can show that a sentence is not a contradiction by giving me an interpretation where it's true. How do we do this? Well, this is where the fun stuff happens. We build models. We build interpretations. We do it by specifying a domain fixing the denotation of any relevant names, if there are any to be concerned with, and most importantly, stipulating the extension of the relevant predicates. Let me give you a few examples. Here's a sentence of FOL. This sentence is not a logical truth. And I'll show it's not a logical truth by building you an interpretation. Let's have the domain be Robin. In fact, probably the absolute best Robin Hood. Amazing. I don't know if you guys have seen this Disney film, but it is amazing. So our domain is Robin and the Fantastic Mr. Fox. We'll have F from our sentence be the predicate is a fox. We'll have A pick out Robin and B pick out Mr. Fox. On this interpretation, our sentence is false. On this interpretation, the sentence is false. There is no object in the domain that we can plug in for X that will make the sentence in the brackets true. So this interpretation shows that this sentence is not a logical truth because there's at least one interpretation where it fails. Easy, right? We build an interpretation to do a job. In this case, to make this sentence false. So it's not a logical truth. Is it a contradiction? Is it going to be true on every interpretation? No, we can show it, right? Let's build an interpretation where it's true. Cool. To show that this is not a contradiction, here's a different interpretation. My domain is Robin Hood. F is still as a fox. A is a name for Robin. B is a name for Robin. A very exciting interpretation. On this interpretation, my sentence is true because there's at least one thing in the domain that you can plug in for X that makes this sentence in the brackets true. So, what do these two quick and dirty examples show? If I give you a sentence, you can prove to me that it's not a logical truth by giving me an interpretation where it's false, and prove to me that it's not a contradiction by giving me an interpretation where it's true. You can build countermodels, models that show a claim is false. That is, sentence is a logical truth. No, it's not. Sentence is a contradiction. No, it's not. Note, what we cannot do is we cannot build interpretations that show that it is a logical truth. In order to do that, we need to talk about every single possible interpretation you could theoretically construct. And have fun trying to write that out. You'll be writing for a very, very, very long time. Similarly, we cannot show, using interpretations, that a sentence is a contradiction. Again, we need to then think about every possible interpretation we can construct. But you can give me countermodels to show that it's not a contradiction and it's not. We can also do other things. For example, we can show that two sentences are not logically equivalent. Can we guess what being logically equivalent is? It's going to be parallel to tautologically equivalent. Means true or false on all and only the same interpretations. Whenever one's true, the other's true. Whenever one's false, the other's false. To show that two sentences are not equivalent, we give one interpretation that makes one of them true and the other false. So here's an easy one. We've got, for all x, x is either an f or a g, and there's at least one thing that's either an f or a g. So to show that these things are not logically equivalent, we come up with one interpretation that applies to both sentences, and it's going to make one sentence true and the other sentence false. So here's my interpretation. Our domain is Jake the dog and Robin Hood. Let's have the extension of the predicate F be Robin. Here's a sneaky trick. Let's have the extension of the predicate G be empty. Now, if it's empty, what does that mean? How many things in the domain satisfy the predicate? None. Remember, Pokemon aren't people. If we have the domain of is a person or being a person, right? Then the predicate is a Pokemon is empty. Nothing in the domain satisfies it. Similarly, if the domain is people in this room, then the predicate is outside the room is empty. Nothing in the domain satisfies it. More importantly, when we're constructing interpretations, we can have the extensions be empty. That's very handy, because on this interpretation, this setting of extensions, our left-hand sentence is false. Why is our left-hand sentence false? So our left-hand sentence says everything in the domain is an F or a G. So we can just plug all the things in. Is Robin an F or a G? Sure, he's in the extension of F. Is Jake an F or a G? Well, he's not in the extension of F, and nothing is in the extension of G. So it's not the case that everything in the domain is an F or a G. But how about our right-hand sentence? Is it true or false? Well, it's going to be true, because all it needs is that there's at least one thing in the domain that we can plug in that's going to be an F or a G. And what's the one thing? What's the thing we can plug in here for X? Who does the job? Well, let's think, right? For that sentence to be true, there needs to be at least one thing we can plug in here that satisfies either the predicate F or the predicate G. And who's our boy? This beautiful, beautiful foxy fellow, right? Note, it doesn't matter that if we plugged in Jake as the X, the sentence would be false. Doesn't matter, because the existential says, hey, there's at least one thing in the domain that does the job. There could be a billion things that don't, but if there's even one, the existential's true. So this interpretation shows us that these two sentences are not equivalent. So far, so good. The last kind of thing that we can do with interpretations, and in some ways the most useful, is we can show that arguments are invalid. And we show arguments are invalid by constructing a counter model, that is, an interpretation, that makes all the premises true, but leaves the conclusion false. Effectively, it's like showing, here's the situation where premises are true and conclusions false. Just doing it in terms of fixing the extensions of the predicates. So, here's an easy one. We've got this claim right here. There's something that makes the sentence in there true. And then our conclusion is, if there's an F, then FA. We're going to construct an interpretation to show that this argument is invalid. My interpretation. Domain is Jake and Robin again. The extension of predicate F is going to be Robin. And A is going to be Jake. Okay. Now note, our conclusion here is false. Our antecedent is true. There's at least one thing that's an F. Robin. So antecedent's true. Is our consequent true or false? Is the thing named by A in the extension of F? Is Jake on this interpretation an F? No, right? He's not on that list. Antecedent's true, consequence false, conditional is false. Our conclusion on this interpretation is false. How about our premise? Our premise says, hey, there's at least one thing you can plug in here that's going to make this sentence in there true. And is there anything in our domain that we can plug in that will make the sentence in the brackets true? Well, we only got two, so let's try them both, right? Let's try Robin. If we plug in Robin for X here, well, then the antecedent's true and the consequence false. So does Robin make the sentence true? No, right? What happens if we plug in Jake? What's the truth value of our antecedent if we plug in Jake for X? It's going to be false, right? It's going to be false because Jake's not in the extension of the F's. And what happens with a conditional with a false antecedent? What's the truth value of a conditional where the antecedent is false? Always true. It's always true. So who is it that makes the premise true? It ain't Robin, it's Jake. So this interpretation is one where the premises are true, but the conclusion is false. This interpretation shows that this argument's invalid. Now, I want to stress, we're going through these quickly. Just talked about how interpretations work. Don't stress if it's not clicking. What we're going to talk about in the tutorials is how to do this. How to build interpretations to show sentences are not logical truths and not contradictions. To show that pairs of sentences are not equivalent. To show that arguments are invalid. I'm going to teach you how to build these counter models. But it's all stemming from the stuff we've talked about earlier. Fixing the extensions of predicates to make the atomic parts true or false, and then letting us determine all the rest from there. Notably, we can also do this diagrammatically. We did this before. For those of you who came to the tutorials, right, I drew the little diagrams with Ron, Harry, and Hermione, and arrows for love. That was basically an interpretation. That was a model. So again, we can do this diagrammatically. We'll talk a little bit about this in the tutorials, but this is just another visual way to build the same kind of interpretations we just did. To go back a slide here. Okay. So we have some really neat kind of things that follow from this. If some interpretation makes some sentences true and the conclusion false, then we get the arguments invalid. We get that the premises don't logically entail the conclusion. We also get that these sentences and negation C are jointly consistent. There's at least one interpretation that makes those all true. Again, this is broadly the idea of building counter models. This is the kind of thing I'm going to ask you to do on the midterm. So, notably though, all we can do is build counter models. We are incapable of building models that prove an argument's valid or prove that a sentence is a logical truth. And that's really strange. So, some general suggestions, because I'm going to ask you to build your own interpretations. These will make your life easier. First, keep your domain small. Try it with one object, with two objects, with three objects at most. Because then you can literally just plug everything in one by one. Remember that you can directly stipulate the extensions of predicates. Remember also, you can directly stipulate the extensions to be all, some, or none of the things in the domain. Predicates can be empty. Predicates can be satisfied by everything. That makes life so much easier. And finally, if you're dealing with two-place relational predicates, think about drawing a diagram. Some people find that much easier than lists. We'll talk more about these in the tutorials. The important thing is that we can see what these interpretations do and how they let us track the relevant semantic properties. Okay. So the thing I want to finish off on, and this will take me just 2 minutes maybe, is again, we can show a lot of things using interpretations. but it's broadly negative. We can show that two sentences are not equivalent. We can show that some sentences are consistent. We can show that an argument's invalid. We can show that some sentences aren't, that some sentence is not a logical truth, not a contradiction. We can't do these things. We can't do these things because in order to do this, you have to talk about every interpretation. So we can do something like this beautiful little picture here, right? Where it says one counter model, we can actually construct those. But when it says all, where you don't have the tools for that. And that's kind of a shame. But the nice thing is, that's what we're going to talk about in the second half of the course. When we come back from the midterm. I'm going to give you another kind of tool that's going to basically match in perfectly with the spots that we can't do here. That's the sales pitch for the second half. Right? So, notably, that's it. That's all the material for the first half up until the midterm. What we're going to do in the lecture next week is I'll talk you through the structure of the midterm exam. We'll talk about any questions people have, so come prepared with questions. And it's just going to be a review. So there's not really going to be much in the way of lecture. Should also note, the practice midterm has now been uploaded. It's available in the assignment due on week 8. Note that it's just an assignment due in week 8 so that you have a kind of motivation to actually do the practice midterm. But it's there, you'll be able to see it. I'll upload some sample answers later on this week. We'll talk about those in the tutorial next week. So yeah, take care guys, have a lovely evening, and we'll see you all hopefully later this week.